The slope is a very important part of linear equations. When written in slope-intercept form, the standard form y equals mx plus b, the slope is the variable m, which is represented by the variable m, which is a number multiplied by the independent variable x. The slope is also called the rate of change. It is rise over run. It is the change in y value divided by the change in x value, which can also be notated as y2 minus y1 divided by x2 minus x1, where you have 2 points, x1, comma, y1, and a second point, x2, comma, y2. The subscripts indicate that this is from the second point, and this is the x value from the first point. Now, slopes can be positive, in which case they are a line that goes uphill. Slopes can be negative, then they are a line going downhill. A slope can be zero. If you have a zero slope, that means that your rise is zero and your run is whatever it is. So if you rise zero, if you do not rise at all, you have a horizontal line. No matter how far I run along this line, I never rise up or down because it's a horizontal line. This is a horizontal line. An example of a zero slope would be y equals 4. An undefined slope, well, undefined, if we look up at our fraction, if you have some value of rise, but it's divided by 0. If 0 is in your denominator, it is called undefined. A line that is undefined will look like a vertical line, because no matter how high I rise up this line, I never run left or right. I only go straight up and down. This is a vertical line. And an example of a vertical line might be x equals -6. All of the x values on this line would be -6. Y can be anything in the world. All of the y values on a horizontal line are the same. So maybe the y value is 4 anywhere along this line. X can change. It can be negative, 0, positive. Now, we should be able to find the slope of a line. Remember, you take the difference in the y values divided by the difference in the x values. So if we are given 2 points, we can find the slope of a line. Here, this is my x1, y1, my x2, y2. So to find the slope, I'm going to take the rise, the change in y, so y2 minus y1. I'm going to divide that by x2 minus x1. That's my rise over run. And I'm going to plug in the values. y2 is -8. y1 is 5, so I subtract 5. x2 is 2. x1 is -3, so I'm going to subtract -3. Note the double negative. -8 minus 5 is -13. 2 minus -3 is 2 plus 3. 2 plus 3 is 5. So the slope of the line that passes through these 2 points is -13 over 5. This is a negative slope because we have a negative out front. I can repeat this through each of these examples, evaluating for the slope. If I end up with a 0 in the numerator, then my slope is 0, and it is called a zero slope. If I have a 0 in my denominator, then it's called undefined slope. I get a 0 in the denominator if the x values are the same. I get a 0 in my numerator if the y values are the same. If I am asked to graph a linear equation that is written in a non-standard form, such as 4x minus 6y equals 12, I could either rearrange this equation to be in slope-intercept form, i.e. y equals mx plus b. If I solve for y, get y by itself. Or I could take advantage of the fact that in order to plot a line, I only need to know 2 points. And solving for the x and y intercepts is often very easy to do, because the x-intercept is always when y is 0. It's some x value when y is 0. And the y-intercept is always when x is 0. It is some value of y when x is 0. So if I look at my equation, 4x minus 6y, if I want to find the x-intercept, then I just make y equal to 0. Well, negative 6 times 0 is 0. So I'm left with 4x equals 12. I'm going to divide both sides by 4 to get the x by itself, and I find that x equals 3. This means that the x-intercept is 3. So I can now plot the point 3, 0. Right there. Now I'm going to go ahead and solve for my y-intercept. My original equation, 4x, x is replaced by 0. So 4x, 4 times 0, minus 6y equals 12. 4 times 0 is 0, so this cancels out. I'm left with negative 6y equals 12. I'm going to divide by negative 6 on both sides. Negative 6 divided by negative 6 cancels out. So I'm left with y equals negative 2. 12 divided by 6 is 2. A positive divided by a negative is a negative. So that means that my y-intercept is negative 2. So if I'm at the point 0, negative 2, I can plot it on my graph. Now I have 2 points, which I can then connect to draw my line. I can put arrows in the end of my line if I'd like, to show that it goes on forever and ever. There is no limit to my domain. X can be all the negative values, all the positive values, and 0.